For those of you just joining us, we have a warm-up problem on the board. It relates with should you hit the gas or should you hit the brake if you're trying to make a yellow. The details of it are on the board. And I'll draw a visual image for all of you too, so you can see what I'm drawing. Whenever you're ready, just put your answers in the Zoom chat and we'll see what people are getting. So here's what we're going to do. while you keep working on it, while you try to figure out some answers, I'm just going to start with trying to determine if we should hit the gas or if we should hit the brakes. What we're first going to do is
The screen's in like made small, so we can't really see the whiteboard.
Oh yeah, I'm sorry. Sometimes I forget. That's what happens when you get old. Your brains get dull. Don't tell that to your parents. Okay. All right. Here we go. There we go. Okay. Gas. Okay. So what I'm going to do is I'm going to position function for this car. What I'm going to say is that x of t is the initial position plus the initial velocity plus the acceleration. And this is for when you're gassing. So what I'm going to do here is I'm going to first assume that my initial position is just 0, just to make my life a little easier. I'm going to assume that my final position is 50. Oh, my final is no. This is for the gassing. Okay, so what we want to do is we want to figure out when it takes for the back of the car to clear the intersection. So the car needs to drive at least 50 meters. Then it needs to drive at least another 20 meters to clear the intersection to have the front of the car hit the intersection, but we need the back of the car to cross the intersection as well. So the car actually needs to drive a total of 73.5 meters, right? It's not enough for the front of the car to be at the end of the intersection. We need the back of the car to clear the intersection as well. So what I'm going to say is that, okay, 73.5 meters is equal to the initial position, which is 0, plus the initial velocity, which is 20. I'm going to say that my time is t. We don't know what our time is. And I'm going to say my acceleration is 1/2 times 1.5 times t squared. This will end up being 0.75. So if you solve the quadratic equation for this, if we solve the quadratic equation, we have some really funny things going in the Zoom chat. Here we go. If we solve the quadratic for this, I think we get that time is like 3.3 seconds or something. I don't remember this off the top of my head. But what this means is that it takes the car 3.3 seconds to fully clear the intersection. So, okay, we know that we can't hit the gas. We can't gas. Unfortunately, we can't gas.
3.14.
Sorry?
It's 3.14.
Thank you. 3.14. Okay, so now we need to, okay, so we shouldn't hit the gas, so technically the answer should be we should hit the brakes. But let's actually look at doing the brakes too. So what we can do is we can, okay, so here's the simpler way of doing it. Simpler way of doing it is just something similar where we would just figure out where we are in 3 seconds when we hit the brakes. So what I'm going to do here is that x of t, let's say that x when t is equal to 3. Basically, what I'm trying to do is I'm just trying to figure out just where my position is after 3 seconds. You could actually probably do something similar for here as well. That would also be okay. I'm just saying, okay, my position, when my position is 3 seconds, I want to figure out where I am. So this is my initial position, which is 0. My velocity is 20 times t. So t is 3 seconds as well, plus minus 1/2 times 4.2, so minus 2.13 squared. So the reason why I'm using 3 here instead of t is I just want to figure out where my car is after 3 seconds. So what I'm going to say is x when t is x is equal to 60 minus 2.1 times 3 squared. This is like what, 18 or so, roughly 18. So my x is something like 42 meters. So after 3 seconds, my car is not in the intersection. It's like right here. So just by this, we should figure out if we should brake. So this is just this very simple way of doing it. So the thing is, actually, technically at this point, the car is still moving. So technically, the car could still go into the intersection. The more actual way of doing this, the more accurate way of doing this is, well, if you instead you do something similar to here, where you set we want to figure out when it takes for the car to hit 50 meters, how long it takes for the car to hit. Okay, so let me try to reorganize my thoughts here. So what you can do is you can also say that it takes you can also figure out how long it takes for the car to fully decelerate. So it takes the car a total of, so my velocity, I want to write a velocity function. My velocity time is equal to my initial velocity plus my acceleration times t. So we want my final velocity to be 0 here. So we know that 20 minus 4.2 times t is equal to 0. So it takes me roughly 5 seconds or so to decelerate. I know this is an exact.
I got 4.761 seconds.
Okay. So it takes 4.71661 seconds to decelerate. Okay, so you're like, okay, well, that means that the car is going to go through the intersection. But if you actually plug this into this equation, the position function for the car here, you will find that the car is actually not through the intersection yet. I don't remember off the top of my head what the final position is, but if you plug this into the general position function for the car here, you will find that the car is not at 50 meters. It's actually somewhere around maybe 48 or so. So even though the car is not fully decelerated when the light is yellow, by the time the car is fully stopped, it still hasn't reached the 50-meter mark. So you're still safe. So that's more of a complex way of doing it, but it's probably more mathematically accurate. Just by doing this, we just know that the car should brake.
It stops
seconds,
after
yes.
47.61 meters.
You said
47.61
meters.
meters, yeah.
Perfect. Okay, so thank you for So what we found out is if we actually figure out how long it takes for the car to stop, and we plug this back into this equation, we'll find that by the time the car is fully stopped, it's only at 47.61 meters. It's not at the intersection yet, not at intersection. And I also got some corrections here. I believe that some people have corrected me and they said the time is actually 3.27 seconds. So yeah. Does that make sense? But besides the memery, does that make sense? Yes, it does make sense. No, it doesn't make sense. Okay, so I'm going to assume that I did an okay job. I think I definitely did a better job in the first period. I butchered first period real bad. So you're lucky. Okay, so here's what we're going to do next. We're going to move into the second part of Mario Kart. I first want to talk about grades. So I've already started grading stuff, as you may or may not have known. I've already started grading stuff. So basically, so one thing that's important is that, okay, first off, if you got an A, your percentage grade is going to show up as 93%. Don't panic, it's just a Canvas thing. Basically, Canvas says that the letter grade A is worth 93%. So even though you may have gotten full scores and everything, it may show up as 93%. That's okay. I don't put your percentage grades in Canvas. I just use the letter grades. So don't worry about that. If you haven't finished everything yet, if you haven't submitted stuff, you may have noticed that I've started putting in some zeros, which is not good. It's okay. Like, you can always submit it later, and I won't penalize you or anything. But for the quarter, I'm putting in letter grades and stuff. So I'm putting in zeros if you had submitted stuff. If you haven't submitted stuff in, I would recommend you submit it very soon, by maybe even today, so I have time to grade it and put it in your quarter grades. Because I prefer not to give anyone zeros. So I would recommend doing that ASAP. If you can't finish it in time, I would at least recommend letting me know. So then I can at least, maybe instead of giving you a 0 for everything, I can just give you no grades, and then I'll just give you a credit for the quarter instead of an F. I think that's preferable for a lot of people. I know some people, if you're a senior, you need letter grades for your colleges. So I would, maybe let me know as well and we can figure something out. But so that's for quarter grades. If you have any particular questions, I would just ask me individually and I'll help and I'll try to answer it. So that's just for quarter grades. And you can, another thing is you can always revise stuff. So I usually give, when I grade your stuff, I give you feedback and I would say, when you get feedback from me, just revise it and resubmit it and then I'll regrade it as is. So yeah. Okay, so if you don't have any questions, does anyone have any quick questions about grading, quarter grades, how I'm doing things, how I've graded things, comments, concerns? Okay, so here's what we're gonna do. We're gonna pick up where we left off on last Tuesday, this Tuesday. So what we're gonna do is we're gonna actually start to do some Excel magic. We're gonna become Excel God today. So if you know what Google Sheets does, it's a very powerful tool that allows you to do a lot of calculations without actually having to do them. It's a very powerful real life skill, and it's I would highly recommend you. So one of the reasons why I want to do this is I want to teach everyone how to do this. It's a very powerful real life skill. 5 years from now, when you get a job and you're like, wow, I need to use Excel, you can remember me as the person who made you good at this. So you can give all your credit to me. Actually, no, I'm just kidding. But this is very powerful and it'll actually make a lot of the calculations we do for this project a lot easier, which is why I want to show you how we can set this up now. So the first thing you're going to do is on the Mario Kart Part 2 thing, there is a link to a Google Sheet. I want you to make one copy of it for your group. So your group should have one copy. However, within the group, within your group copy, I want you to make a bunch of individual worksheets for each person. So I have my screen right now. I'll just put a link in the chat right now so you can at least see what the spreadsheet I'm looking at. So there are 4 main race courses: Mount Akina, Monaco, Le Mans, Formula 1 Shanghai. So I would rename this to for example, Mount Akina dash Mr. Who, if you are the person working on it. So that way I can see who's working on who's specializing in what course. If you have 2 or 3 people, just work on 2 or 3 of the courses. And you have 5 people, then you should have 2 people working on the same course. But each person should have their own spreadsheet, a worksheet for that. So yeah, I just make sure each person has one worksheet they're working on. Then what I want you to do is I want each person to make their own copy of the example. Oh, not make it a copy, but I want you to make your own worksheet here on the side, add sheet. What the goal is that you're all going to try to essentially recreate the example worksheet that I made for you. Basically, I'm going to show you what I've done in the example worksheet. Basically, what I've done is I've taken a bunch of, what I have is I have a bunch of statistics here. I have some example statistic for my acceleration, example for my velocity, example for handling, example for braking, example for bad weather. And so I have 20 points in acceleration, I have 10 points for velocity, 4 for handling, etc. And so what I've done here is I put them into 2 rows. And then what I've done here is I've actually converted these into the raw values. So what I've done is I've converted this into my physical acceleration. So 5 plus v2 times 1. I've converted this into my velocity. I've converted this into my actual handling, converted this in my braking, converted this in my bad weather. That's what I've done. So what I first want you to do is I first want you to, in your own spreadsheets, whenever you get the chance, I want you to go to your own individual scenario, and I want you to convert all these kilometers into meters. And I'm going to show you how you do it. So in this example 1, hold on, I'm going to clear this out. Okay, so normally, what you might do is you might do something like, okay, well, 3 kilometers, that's 3 kilometers times 1,000 meters. So I should multiply by this by 1,000. So therefore, this is 300 meters. Okay, the next one is 300 meters, and this one's 300 meters. And this is like really slow, because you have to do for each one. What you can do instead is this is where you should 100% pay attention if you aren't already, because this is where I work some Excel magic. So what I'm doing here is I'm first typing the equal sign. And the equal sign basically refers to, okay, you want to use a formula to generate the value for this cell. So each one of these little grids things is what we call a cell. And when I type in a formula, it means that I want to, write a formula for this. And so what I'm going to do here is I'm going to click this tab, this cell here, B2. And what this means is that, okay, I want to take the value from B2 and I want to convert it to something. So I'm going to take the value of B2, which is in kilometers. I'm going to multiply it by 1,000 to convert the kilometers into meters. And bam, I have 300. Okay, so you're like, okay, Mr. Hu, that's not very interesting. But right now, what I'm going to do is I'm just going to drag this formula and I'm going to drag the bottom right corner of this all the way to the bottom. Oh my God, wow, I just converted every single thing in this column to freaking meters. So can I get a bunch of reacts in the chat, a bunch of crying emojis? I don't even know if you can, but if you can get some crying emojis, that'd be good. Or some wows in the chat. Oh my God, so amazing. Oh my God, no way. Pog, play the game. Wow. Yes, I know, I'm really good at this. Okay, so yes, I'm so cool at this. Okay, so you're like, okay, Mr. Hood, I'm not that impressed. And I know you think you're really cool, but I'm not that impressed. Well, I'm gonna do the even more complex one. I'm gonna convert this kilometers an hour to meters per second. So what I'm gonna do here is I'm gonna say, okay, I'm gonna take this cell, which is D2, which is my kilometers an hour. I'm gonna convert this into meters. So I'm gonna multiply it by 1,000. And then I am going to convert that meters an hour into meters per second. So I'm gonna divide by 3,600. And bam, I just converted this kilometers an hour to meters per second. I drag this all the way down here. Bam, a bunch of conversions done. And the thing is, not only are these conversions, not only can you convert a bunch of things at once, a bunch of numbers at once, you can also, if you change this, if I change this from 290 to let's say 350, it'll automatically be recalculated for you. You don't even have to do the recalculation by yourself. So very, very, very powerful. It makes their life a lot easier. So what I want everyone to do is I want everyone to take, a couple minutes for your own individual race course. I want you to convert all of the kilometers into meters, and then I want you to convert all the kilometers into meters per second, kilometers an hour to meters per second. You can ignore the adjusted speed for now. We'll talk about that later. But I want to give everyone a couple of minutes to figure out how to do this. If you have any questions, please let me know, and I'll show you how I did it again. But for now, I just want you to do that. Get your hands a little dirty in terms of excelling. And yeah, also feel free to tell me that I'm really good at this. There's nothing I enjoy more than having my ego boosted. So yeah, give it a couple minutes to figure this out. Okay, so does anyone need more time? I don't know. I don't know if people need more time.
A little bit more time, please.
Okay, sorry. Okay, sorry, just checking. So does anyone need more time? Is that hopefully well enough time? Okay, so what I want you to do next is I want you to make 2 rows in your Excel sheet that look like this. We have your statistics, or you have the individual statistics of your car. So you have, this is the points value, not the meters per second values. So I want you to make one for acceleration, your velocity, your handling, your braking, and your bad weather. So it should look something like this: 20, 10, 4, 15, 30. And then whenever you're done with that, I want you to make another 2 rows below that say acceleration, velocity, handling, braking, and bad weather. But for the rows below it, I want you to use your statistics to figure out your meters per second values. So if I remember correctly, it's I don't want you to type in your numbers. I want you to write a formula that calculates it for you. So I think for example, your acceleration here should look something like 5, which is the default value that all cars have, plus the value in your initial cell, the cell above that, B2. You don't need this ×1 here, but that's just to show you how I got it. Each point in acceleration increases your acceleration by 1 meters per second squared. Your velocity should look something like this, where it's your initial velocity, which is the velocity that all cars start off with, which is 40. And then you're going to add in your velocity statistic multiplied by 4. So it should look something like 40 plus this cell, whatever the cell is called, times 4. Your handling is just going to be your handling cell times 4. So if my example is D2, the name of my cell is D2 times 4. Your braking is just going to be literally the inverse of your acceleration. You start off with -5 braking, -5 meters per second squared, and then you're going to subtract, or you're going to subtract E2 times 1, or add E2 times -1, or whatever cell your braking cell is called. Each point of braking adds -1 meters per second squared to your braking. And then last but not least, your bad weather. The way I did mine is I just took my bad weather statistic. Each statistic is, I believe, a 3% reduction. So what I did is I took 30 points in bad weather and multiplied it by 3 to get a 90% reduction. And then I divided by 100 to get 0.9. You can do this bad weather a little bit differently. This is how I did it. You'll see later on what I mean. Yeah. Because this bad weather calculation is very finicky. And you may want to do this a different way that makes more sense to you. This is the way I did it to get it to work. And I'll show you what I did in a second.
Where do we do this?
In your so in each person you should make a copy, or you should make your own news worksheet inside the spreadsheet. So worksheet is like one of the tabs at the bottom. Each person should make your own. That's not your race course one. So like I might make one here called like Mr. Who statistics, and that's where I would make it. And so I would take these 2 values here. So you might do something like this.
Hey, sir, sorry, but should we have each our copy of example, or do we just take, for example, Le Mans or Shanghai? Then we do this on here.
Each person should have their own copy of the example. Or
Okay.
like, not necessarily a copy, but you should have a blank worksheet dedicated to your own calculations. It's for practice. Yeah, because it'd be very helpful to get some practice in. Yeah, so take some time to set up your calculations to figure out how to calculate your acceleration from your statistic. And to see if it works, you can always just play around with it and change your acceleration. So I'm going to change mine from 20 to 30, and you'll see that it's already recalculated for me on the bottom cell. Whenever you finish, next thing you're going to do is you are going to put. I guess it depends. I guess it depends how you want to organize it. I have mine organized this way. It may not make the most sense for most people, but you should have a column or so, or maybe a row called downhill, snow, rough roads, and rain. These are the 4 like terrain modifiers, if you want to call it that. But basically, these are just sort of the modifiers that affect your acceleration, your velocity, your handling based on the conditions. And so you'll sort of see, how this works. So what I did here is I typed in downhill, snow, rough roads, and rain, corresponding to each one of the 4 courses. And then on the side here, I have included the penalties for each one. Again, so how you want to write out these penalties is up to you. This is the way that made most sense to me. So if it's a 50% increase, what I did is I just said, okay, it's 1.5, and a penalty is 1.5 because it's a positive penalty. It's a my velocity from downhill is a positive penalty, so I wrote 1.3. My handling penalty, it's a 30% penalty, so I just wrote 0.3. My braking penalty, I think it was 40% penalty, so I wrote 0.4. And I did this.
I have a question on how
Yes.
these penalties apply. So when you say it's a penalty, does that mean you're multiplying your values by that amount, or you're adding that? I'm
Okay.
very and like,
Yes,
are you
okay.
doing your points or like the stuff that you've done after you've applied the calculations to it? Like,
Okay.
how do they?
Good question. Okay, so good question. Okay, so you can ignore this for now because we'll use this later. What I'm going to write this down here. So let's say I have 20 points in bad weather. So this would mean I have a 60% reduction. We'll use this in a second. Okay, so let's say my handling penalty is 40%, which means that, okay, let's see my velocity penalty was 40%, which means that my actual value should be 60% of what it used to be. So if I have a velocity of 10 meters per second initially, after the penalty, it'll be 6 meters per second. So there's a 40% penalty, which you can think of it as it's 60% of what it used to be. I think this part is okay, not too bad. The harder part is the reduction. So
Wait, so if it was like a 1.2 penalty, how would that work?
okay, 1.2 penalty would mean it's a bonus. So if it's a 1.2 penalty, you would just take your a 1.2 penalty is a 20% increase. So this would be 10 meters per second. and this would be now it'd be 12 meters per second. Does that make sense so far?
Makes more sense, yeah.
Okay, so now I want to start talking about the reduction. So the reduction means that you're going to reduce how much penalty you have. So if I have a 40% penalty, what I'm going to do is I'm going to reduce this by 60%, which means you can think of it as I'm going to take a 40% penalty and I'm going to reduce it by 60%. So I am going to I'm going to multiply by 0.4. And so now my new penalty is 16%. So now if I were to actually convert my velocity into my bad weather adjusted velocity, it would be 10%, or 10 meters per second times, so a 16% penalty is essentially multiplied by 0.84. So my new velocity would actually be 8.4 meters per second. And then if it's a positive thing, you don't need to convert. You don't need to adjust you don't need to adjust it for bad weather. So this one would always just be this one. Okay, so to sum up, if you have a 40% penalty, you can think of it as it's 60% of it what it used to be, or you just multiply it by 0.6. So if I initially had a 10 meters per second velocity, after the penalty, it'll end up being 6 meters per second. If I have a reduction in bad weather, so if I have a 60% reduction in bad weather, it's essentially meaning, okay, I take my penalty, which is originally 40%, I multiply it by 0.4, and so I get my new penalty is 16%, or you can think of it as I'm multiplying something by 0.84. And so now if I take my velocity, multiply by my new penalty, it'll be 8.4 meters per second. Does that make sense for people? So I will leave this on the board right now. Okay, I'll put this back up in a second. I just want to show you what we're going to do with this. So what you're going to do is you're going to make so this is how I structured mine. I just wrote it in terms of, okay, if it's a 60% penalty, if it's a 40% penalty, I'm multiplying by 0.6. If it's if it's a 60% penalty, I just wrote it as 0.6. If I have a 55% penalty, I wrote it as 0.55. This probably doesn't make the most sense from a statistical standpoint, from a conceptual standpoint. This is just how I structured it. And then what I did here is I did some, I basically wrote down a formula to calculate what my new braking is using these different penalties. So what I did here is I just wrote down that, okay, if it's a 40% penalty, I did one minus that to convert it to 0.6. I multiplied it by my, what I did is I took my braking penalty, I subtracted it by Okay, I did 1 minus my bad weather to get how much my new to get my multiplier for my bad weather. I multiplied my braking penalty, and then I did this. Yeah.
So the bad weather thing is affects all of the penalties. So all the penalties are
except the positive ones, except the ones that help your car. So so there are 2 of them. So these 2 aren't going to be affected. So this one, these 2, but everything else it'll be affected.
Okay, so literally every negative penalty.
Yeah.
Is okay. Cool.
What is the AV handling penalty and braking penalty? Should we change them, or are they always the same?
These are going to be always the same, basically, because these are the you don't need to calculate these. These are just the numerical values that I've given you in the race course. How you want to write these out may be a little bit different. For example, instead of saying 0.6, you may want to say 0.4 if that makes more sense for you in terms of how you're going to use it to calculate stuff. This is what made the most sense for me. The only thing that matters for me is as long as you can use these values here to figure out your adjusted values. So for example, what you may do here is you may just take, again, it's up to you how you want to do it. Sorry, so I'm being it's a little confusing because, yeah, so you can keep these as this if you feel like that's going to help you, and then you're going to try to write a formula to use these adjusted penalties to create your adjusted values. So I have all my adjusted values here, and you can see the formula I use. What I want you to do is I actually want you to try to recreate the formula from scratch. Recreate some formulas from scratch just so you can get some practice. And I'm going to show you on the board some things that you should definitely think about using. I don't want you to just type in the formula each time. I'm going to teach you how to do some dragging and dropping. So right here is I have written down 3 things that you should know. So when you're in general, if I'm selecting a cell, I might just select, if I'm working with cell D2, this is the cell I'm working with. And so when I'm literally dragging and dropping down, if I'm dragging or dropping down a formula, what it's literally going to do is it's going to literally apply it to the corresponding cell. So if I have a cell here that's working, if I have a cell here D2 or E2, let's call this E2, and I'm trying to use D2 for a calculation, when I drag this formula down to, let's say, E3, it's going to pull a formula from not D2 but from D3. And if I drag this formula horizontally to DEF to F2, this is actually instead of pulling from D2, this is actually going to pull from E2. I don't know if this flowchart makes sense, but hopefully it does. So basically, each one is going to pull essentially from the corresponding cell. However, this may not actually be what you want. Sometimes maybe you only want to restrict things to a particular column. So if you drag it horizontally, maybe you're like, okay, I don't want to, maybe if you drag it horizontally, maybe you don't want to pull values from E2, maybe you still want to pull values from D2. Or maybe if you drag things downwards, maybe you want to just restrict it to values within that particular row. So this is where you would use these dollar signs. So when you have the name of the column D with a number with a dollar sign and then the number afterwards, this number is D should be column, your number should be row. And so if you want to restrict formulas to a particular row, you're going to stick the dollar sign in between. Which means that if you drag formulas down, it'll restrict things to a particular row. When you want to restrict formulas to a column, you're going to put the dollar sign in the front. which means that if I drag formulas to the right, it's going to restrict it to this column. And so therefore it won't, it'll just keep using the same value in the column. The last one here is if you have $2 signs. You have $1 in the front and then one in the middle, which means that you want to restrict a formula to use that column and that row, which pretty much just means you're going to use one cell. If you always want to use one cell, and this is helpful if you have like one particular value that you always want to use, that you never want to change when you drag your formulas around.
Question, when you say restricts formula to that row, what do you specifically mean by that?
Okay, so let's say I have cell. So let's say, here's what I do. I'm gonna write two scenarios. No restrictions, and then yes restrictions for rows. So normally what happens is that I have a cell. I have a cell E2, and I'm pulling from cell D2. I'm using D2 as a formula. If I drag the formula, if I drag the formula down to E3, it's going to pull from D3 instead. Now, if I put a restriction, so if I put this D or this D comma 2 restriction, what's going to happen is that I am going to, if I have E2, that's pulling from D2. If I drag the formula down to E3, right, it's restricted to this row. So it's still going to pull from D2. And if I drag this formula over to F2, because it's restricted to the row, but it's not restricted to the column. So this F2 is going to pull from E2, which you may or may not want. And then if you drag this F2 down here to F3, it's still going to pull from E2 because it's restricted to that row. Whereas here, if I pull this over to F2, right, it's going to pull from E2. And then if I pull this down to F3, it's going to pull from E3. So see, what I've done here is every time I pull a formula down to, let's say I pull this down to E4, I'm only using values from this particular row. Whereas here, if I pull a formula down, I can use any row I want. Does that give you a better idea?
Yeah, that makes a ton more sense. Thank you so much.
Okay. So I think this is hopefully the best way I've figured out how to explain this because it's kind of complicated. What I found is very helpful is trial and error. You try out like different setups for your dollar signs, and then when you look at the formulas that it gives you, you'll see that if it makes sense or not, if that's what you want. I found that to be helpful. Okay, so what I want you to do now, we'll take the rest of this period, and we'll keep working on this next period. I want you to see if you can essentially recreate the formulas that I wrote for you, or you can write your own to figure out how you can create your bad weather adjusted values for your handling, your velocity, your acceleration, etc. And I want you to see if you can use these dollar signs and stuff to essentially write them for yourself as a way of good practice. So I'll give you the rest of the period to do this, and we'll keep working on this next Tuesday as well, because this is a very important skill, and I want everyone to feel comfortable with it. And we'll have plenty of time to keep doing this. So yeah, that's what we're doing right now, and then I'll go around and see how everyone's doing. Hello, everyone. How are you all doing? Oh, okay, I know it's muted. Okay, so sorry. Okay, so 9:57. I'm really sorry, kept you 2 minutes over. No homework other than to finish City Skylines if you haven't done so already. You don't need to try to finish this Excel stuff over the weekend. We'll pick up where we left off on Tuesday because I know it's kind of difficult. If you want to mess around with it over the weekend, you're more than welcome to, but I don't, you don't have to. Otherwise, no homework. You're free to go. Sorry I kept you over. And have a good one. Have a good weekend. And do City Skylines if you haven't done so, or let me know where you are.
Please. Thank you.
Thank you, Mr. Hu.
Okay, bye-bye.
Thank you. Have a good weekend.
You too.
Mr. Hu,
Yes, go ahead.
I resubmitted my City Skyline parts 3 and 4 with like revisions and stuff. So yeah, I just want to let you know just so that you're aware of that.
Yeah. Okay. Thank you for letting me know. I'll try to regrade it today.
Yeah,
We'll
no,
be off time.
yeah. All right, thank you so much. All right.
Mr. Hu,
Yes.
hi, I was wondering what I should do or when, because I missed like all of last week, so I was wondering when you need the work by that I missed.
So okay, so did you, I think I graded your, let's see, which ones have I graded? So which ones have you submitted for City Skyline?
I submitted the first one. I was gonna do the second part. I realized it was due and that I didn't have it done, so I was gonna do it the weekend that I got the appendicitis, but then I ended up spending
Yeah.
in the hospital.
So since you had your appendicitis, which is very fun, it sounds very fun. So what I can do, so what I'll do is, what I'll do is I'll not grade it for now, and I'll just give you a preliminary grade based on your part 3. And then if you submit it over the weekend, I may be able to incorporate it into your quarter grade.
Okay, and quarter grades don't matter for juniors, right?
Yeah. You could have an F right now. I don't think anyone would care. Maybe besides your parents, but yeah.
Okay, cool. All right,
Yeah.
thank you.
No problem. Samir, do you have a question for me?